Good morning all of you. Today we are going to discuss effect of feedback and transfer function of control systems. Okay, subject control systems, right? So in the last class we have discussed the classification of control systems, within that open loop control systems and closed loop control systems, and their practical examples, and also advantages and disadvantages, right? So continuation. Today we are going to discuss feedback and effect of feedback on different parameters, and also we'll see transfer function. Okay, so let us start feedback. So feedback. Okay. So what do you mean by feedback actually? See, feedback is the one of the major property of closed loop control systems, as we discussed in the earlier also, in the last class also. Okay, while discussing closed loop control systems, what is the difference, major difference of open loop and closed loop? Major difference is closed loop systems consist of feedback path, right? So due to the feedback path, whatever the variations happening in the system, it is automatically corrected at the output. Therefore, we will get desired output. The output which we want, right? So controlled it, I can say that, right? So the major one is, first point, I'll write here. The first point, feedback is a property of closed loop control systems. Okay, so feedback is one of the major property of closed loop control systems. Okay, right. So what is the use of this feedback? Okay, due to the feedback, okay, output will be compared with the input to make corrections. Okay, whatever the errors, okay, to remove the errors, okay, it will compare to the input, and automatically the output will be controlled. Output will be desired one. Okay, so that is the major use of the feedback, right? So the second point, feedback permits the output to be compared with the input of the system, so that the appropriate control action may be formed. Okay, so feedback, this is the second point, right? So the feedback permits the output to be compared with the input of the system, so that the appropriate control action may be formed, right? So let us see advantages and disadvantages of the feedback system, right? A feedback path. So let us discuss. Of feedback. Okay, so see here, we have few advantages and disadvantages of feedback, but this is with condition this must be designed properly, then only we have advantage. If we are not designed properly this feedback, then automatically these are the disadvantages again, right? Let us see. So the condition is what? We need to design, proper design must be taken. Okay, feedback, see, system if more stable, which means what? The feedback is perfectly designed. If system is gone to instability, then it is nothing but feedback is not designed properly. Okay, we need to design again, right? So let us see the first one. Okay, so as we discussed in the concept of closed loop control systems, okay, so it will be increase the accuracy. So by using this one, increased accuracy, okay. Second one, see it will, if we design proper design, if we taken proper design, then the sensitivity also reduces. So we need to maintain sensitivity very less. Okay, so by using feedback, reduced sensitivity. Okay, so this is very important factor actually, right? Next is reduces effects of non-linearities and distortions. Okay, so this is also there. Then it reduces effect of non-linearities and distortion. Okay, fourth points. So if you maintain proper gain, overall gain, then the bandwidth also increased here. So here increased bandwidth. Okay, so advantages of feedback, okay, with the design is a major factor I already told. Okay, then we have increase the accuracy, reduce the sensitivity, reduces non-linearities, distortions, okay, and also increases the bandwidth, right? Next is the disadvantage. So we'll see the disadvantages here. See here, whenever the feedback is not properly designed, then it will undergo to oscillations. Okay, therefore the system will leads to instability. Okay, so we'll write that one. Tendency towards oscillations. Okay, so tendency towards oscillations, I can say this is one of the disadvantage. Okay, so if design is a major factor, feedback design is another major factor. Okay, if you not design, then automatically system leads to instability. Okay, so these are the advantages and disadvantages of the feedback, right? So next we will see effect of feedback. So this is one of the important topic again, effect of feedback. Okay, right. So see, there are so many parameters, okay, which the feedback will be affects, right? The first one is, say, the first one is gain, okay, gain of the system, and the second one is, as we discussed, sensitivity, okay, and the third one is major one, stability. Okay, so we will see effect of feedback on these parameters: gain, sensitivity, and stability. Okay, so let us see the first one. Right, effect of feedback. So the very first one, effect of feedback on gain or overall gain, you can say. Okay, right. So this is the one of the important here. We need to consider the overall gain of the system. Okay, so what is the overall gain? So the overall gain is what? T is equal to C by R is equal to G by 1 plus G into H. Okay, so this is the overall transfer function we have, right? So so what we consider here, we need to consider this factor. So this, okay, we need to consider the factor of 1 by 1 plus GH. See here, so this is the feedback element, right? So if I take, if 1 plus G into H is less than 1, so what will happen? The gain will be increases in the negative feedback. Okay, so basically I considered here negative feedback is here negative, right? So negative feedback, right? So if 1 plus GH is less than 1, then therefore the overall gain is increases. Okay, suppose if 1 plus GH, this factor, is greater than 1, then what will happen? The overall gain will be decreases. So here, therefore, the overall gain is decreases. Okay, got my point? This is the effect of feedback on overall gain. See, in the negative feedback, I considered here negative feedback. Okay, whenever this particular factor, feedback factor, okay, this feedback factor is less than 1, then the overall gain will be increases. Okay, when this particular feedback factor is greater than 1, then it will be decreases. Okay, so this will be say opposite in the positive feedback, right? Okay, okay, next we will see, second point we will see sensitivity. So I can say this one, effect of feedback on sensitivity. Right, right. See here, how will you consider this sensitivity? See, sensitivity is nothing but how much the system respond to a change in parameter or input. Okay, simply I can say, I can write this one also. See, sensitivity is nothing but how much the system respond to a change in parameters are say input. Okay, so sensitivity, we need to consider whatever the parameters consist in the closed loop system, and also what input we are giving. So these these two parameters will be major for sensitivity. Okay, so let us see. The first point, if I say the control action will be taken sensitivity with respect to parameter, and the system will be taken sensitivity with respect to input. Okay, so this is say the control action whatever we have, right, and this is will be the remaining part of the system, right. Let us see. So sensitivity is given as sensitivity, the overall gain, okay, with the parameter is equal to the percentage of change in overall gain divided by percentage of change in parameter. In this case I took K as a parameter, right. So therefore this will be given as change in temperature all divided by change in parameter. Okay, so if we consider this is percentage 100%, right. So therefore this will be taken. Okay, so this is K by T into dou T d by dou K, right. So this is the sensitivity. Sensitivity is nothing but what? The percentage of change in the overall gain divided by the percentage of change in the parameters. Okay, so parameters in the sense say feedback path or forward path, whatever the elements present in the system. Okay, that we need to consider. Okay, got my point? Right. Now we'll apply this sensitivity, how it will be effect on the feedback. Okay, so let us consider closed loop system. Okay, I'm taking a closed loop system here. So as we know, this is the summing point, this is forward path. Okay, so forward path I'm considering as a Z, and this is C of S, the output, and this will be the R of S, input. Now we have a feedback here. This will be taken as a H of S or H. Okay, so this is negative feedback here. Okay, whatever. So the overall gain or transfer function is given by G by 1 plus GH due to the negative feedback, right. Now let us find the sensitivity of this particular system. Okay, so see here, S the overall gain into G. So first of all I am considering the forward path. Okay, this factor. So what will happen if I changes the forward path G? So what sensitivity will affect on the system? That means what? The output action, right? So let us see. So this will be as per formula G by T into dou T by dou G, right? Now I will take this one. Okay. Now so calculate dou T by dou G, which is nothing but dou by dou G of the what is the transfer function? G divided by 1 plus GH. Okay, so this will be U by V form. Okay, let us do it U by V form. Okay, right. So we will take U. This is so 1 minute. So this will be U, V, and this will be U, right? So therefore, just go ahead. 1 plus GH into 1 partial derivative with respect to G is 1 minus, so what is the next term? G into, so the total term with respect to G is H, right, divided by V square, that is nothing but 1 by GH whole square, right? So this will be taken 1 plus GH minus GH divided by 1 plus GH whole square. Okay, so these two terms will get cancelled. Now the final one will be okay, 1 by 1 plus GH whole square. Okay, so let us complete this term. Therefore, the sensitivity of the forward path G is equal to, so we have this one, G by T. So G, what is the T here? T nothing but the overall transfer function 1 plus G into H, right? Into this term. This term already we got this value. So that is what? 1 by 1 plus GH whole square. Okay, so which is taken as G into, cross multiplying here, 1 plus GH divided by G into 1 divided by 1 plus GH whole square. Okay, so this term will get cancelled. Okay, and G also get cancelled. Now what is the final term? 1 by 1 plus GH. Okay, so finally we got the sensitivity, the temporary, the forward path. Okay, we got this factor 1 by 1 plus GH. Okay, right. So what will happen with this? Just see here. See, this particular factor, if I consider this one 1 by 1 plus GH is less than 1. See here, if we consider, okay, GH is a positive number. Okay, if it is a positive number, therefore this value must be less than 1. Okay, that means what? Therefore percentage change in gain, the overall gain is less than percentage change in G. G is nothing but forward path, right? So see here, if I change forward path gain, for example, okay, so it is not that much effect to the overall gain. Okay, so it will less affected by whatever the changes happening in the forward path. Okay, so this is the sensitivity, right? So I can say in our system, closed loop system, if I make smaller changes in the forward path, okay, so the output doesn't affect that much. Okay, so it can be happen, no problem, we can change that. But whereas the feedback, let us see the feedback also. So this is one. Now we will take sensitivity with respect to H. Now feedback in the closed loop. Okay, H is the feedback. Now we will take this also, the sensitivity overall gain with the parameter is equal to, what is the formula? We have H by T into dou T by dou H. Okay, where overall gain is equal to, we know, G by 1 plus GH. Okay, so let us solve this. Let us solve this. Okay, so first of all I want to know dou T by dou H. Okay, which is nothing but dou by dou H of T. T is what here? Overall gain, G by 1 plus GH. Okay, so our system is consists of negative feedback, that's why 1 plus GH, right? Now U by V formula again. So this is nothing but 1 plus GH into 0, there is no term, right? Next one is G into H, so G, right, divided by V square, that is 1 plus GH whole square. Okay, minimize this one, so minus G square divided by 1 plus GH whole square, right? Now take overall the value, the sensitivity, the overall gain with respect to feedback H. Okay, so therefore this is H by T as the formula, right? This one I am taking here into this function. Oh, already we got this one, that is into minus G square divided by 1 plus GH whole square. Okay, shall I move up? Right. Okay, no problem. Right. Now calculate this one. So H divided by, what is the T? T is the overall gain, that is G by 1 plus GH, right, into minus G square divided by 1 plus GH whole square. Minimize this one, H into taking 1 plus GH divided by G into minus G square divided by 1 plus GH whole square. Now GG will get cancelled, this term will get cancelled. Now final will be minus GH, these two terms H and G with minus whole divided by 1 plus GH. Okay, so this is sensitivity with the overall gain of feedback. Okay, right? Now we'll see this one, how will it affect. See here, if I consider the GH value is very greater than 1, then what will happen? See here, the sensitivity of feedback is almost minus 1. Okay, see, if I consider this value, okay, if I consider this value, okay, is very greater than 1, okay, then this will be one big value becomes a minus 1. Okay, so the one neglected, so this both are minus 1, we can consider here, right? Got my point? So hence here what happened, negative sign indicates the change in overall gain and the change in the feedback H are opposite, which means it indicates the opposite. Let us see, I will write that also here. Minus sign indicates this minus sign, okay, indicates that the change in the overall gain and change in H are opposite. Okay, so I write they are opposite. Okay, which means what here? Which means what? If H increases, therefore the overall gain will be decreases. If the H is feedback is decreases, then overall gain will be increases. The sensitivity, okay, sensitivity of, I can say, sensitivity of feedback increases, then the overall gain will be decreases. Okay, the sensitivity of feedback is decreases, then the overall gain will be increases. Okay, so this is major important. Then what will happen? See here, we can see while designing a system, closed loop system, we can go with small changes in the forward path but not in the feedback path. See, if any changes in the feedback path, it will affect automatically to the output. Okay, so see here, it is a transfer function g by 1 plus gh. See, these, if this one increases, okay, so this one decreases. If this one increases, then this one decreases, right? So we should not make any changes in the feedback. If you change feedback, any changes in the feedback will affect the system output. Then system leads to instability. This is okay. So major part. Sensitivity is what? Two things we need to know here. In our control systems, if I made any changes in the forward path, okay, then in the overall gain there is a small changes, okay, but when we have a changes in the feedback, then the system leads to instability. Okay, so whenever we show that whenever we changes the feedback, then the system will leads to instability. Okay, so design factor is very important with the feedback, right? Here see, sensitivity, we need to consider only magnitude of S, right? So here one point I can write, this is important note. Okay, here we need to consider only magnitude of sensitivity. Okay, even though we will get the complex, we need to take that into magnitude, because it is the ratio of change in overall gain divided by change in the parameter. Okay, so whatever the change happen in the parameter, then automatically changes will happen in the overall gain, right? So this is sensitivity concept. Okay, so in such a way, the effect of feedback will take on a sensitivity. Right. Now we'll see the stability. So third one, effect of feedback on stability. Okay, now okay, see here, what do you mean by stability? Actually, stability is nothing but it is a motion that describes whether the system is able to follow the input command or not. When we say system is proper, whenever we have a desired output, controlled output, then the system is said to be stable, otherwise unstable. Which means what? There must be a perfect communication between input and output, or output must be follow the input command. Okay, whatever the input command is varying, so output must be follow that one. Then the system will be accurate. So the system is said to be stable one, right? So this is very important parameter, one of the very important parameter we have, right? Let us see. I will write. So what do you mean by stability actually? Okay. What do you mean by stability? Right. I will define here. Stability is a motion that describes whether the system will be, you can say, will be able to follow the input command. Okay, stability is a motion that describes whether the system will able to follow input command or not. Okay. Right. Now so we know that the overall gain of the system will be C by R is equal to G by 1 plus GH. This is for negative feedback. Okay, I can say this is for this term I am taken as a negative feedback. Okay. So suppose, see here, if I consider the G of H term will be negative, okay, then see here the system is leads to instability, which means what? If I consider this is a -1, for example, okay, G of H is equal to -1, what will happen? G by 1 minus 1, that is G by 0, that is leads to infinite. Okay, so what will say this one? System is unstable. Got my point? See here, see this is the one of the disadvantages. See, due to the feedback element, okay, suppose this is a feedback element, if I found this is -1, so therefore our system leads to instability. Okay, so this is the one of the disadvantage, right, for the stability with the feedback, right? So therefore how to make stability with unstable system, right? So see here, suppose this is our system, for example, okay, this is output and this will be the input, and we have our feedback H, this is G. Okay, so I consider here negative feedback, right? So see here, with this we have -1 this value, right? So with this our system leads to instability. Okay, unstable system becomes, right? So to make it stability, we need to connect another feedback here, say H1. Right? See, so with this again we will make this unstabilized system to stable system. This is the another advantage. Okay. So see here we have a disadvantage as well as advantages of feedback. See, whenever with the effect of feedback only, system leads to stability. Okay, if you design properly with another feedback or number of feedbacks to the system, then we make unstabilized system also stable one, right? See here, I will write that also. So it can be demonstrated that one of the advantage Advantages of incorporating feedback is that it can be stabilize an unstable system. This is important. Okay, so it can be stabilize an unstable system by adding extra feedback with proper design. Okay, so this is the effect of feedback on various parameters like gain and sensitivity and stability. Okay, so while designing we need to take care about feedback loop. Feedback is a major factor. We need to design proper, right? Okay. Now let us see the transfer function of control systems. Okay, so let us see this. Okay, transfer function. Okay, let us see the transfer function. So what do you mean by transfer function? Okay, so simply the relationship between input and output of a system is nothing but is given by transfer function. Okay, so basically the transfer function is defined as the ratio of Laplace transform of output, that is a response, okay, of a system to a Laplace transform of input, okay, when initial conditions are 0. Okay, so that is the transfer function. Okay, so what is the need of transfer function? See here, for any given system, okay, so how to find the stability of a given system? How can you say that this system is functioning properly, okay, performing properly? Then for that particular system we need to consider input, output, the particular ratios, okay, that is nothing but a transfer function. Then we need to find with various methods, using various methods we will find the stability of a given system. Okay, so it is very important that for any given system we need to find the first of all transfer function, okay, to check its performance, right? So see here, transfer function. So what is the transfer function? The relationship, sorry, the relationship between input and output of a system is given by the transfer function. Okay, if I write the definitions here, so let us see definition. Okay, so the transfer function is defined as the ratio of here Laplace transform of output, so I can say output is a response, okay, of the system to Laplace transform of input when this one under, okay, under the assumption that all initial conditions are 0. Or 0. Okay, see here, transfer function definition. The transfer function is defined as the ratio of Laplace transform of output or response of the system to a Laplace transform of input under the assumption that all initial conditions are 0. Okay, so you need to make all initial conditions must be 0, right? Suppose I have a system. So this is taking one system here, and system, so I'm naming it g of t, okay, which is consisting of output c of t, and I have a input r of t. Okay, now this will be through the Laplace transform. You can write system g of s, this one is the c of s, and our input will be the r of s, okay, after Laplace transform. Okay, so for this system, for the system shown in the above, shown this one, c of t is nothing but output, and r of t is nothing but input, and g of t is nothing but system function. Okay, so whereas by taking Laplace transform, okay, so their Laplace transforms, what will you get? Laplace transform of c of t. What is that? c of s. Okay, so Laplace transform of r of t is nothing but r of s. Okay, then Laplace transform of g of t is nothing but g of s. Okay, right. Therefore, if t of s is the transfer function of the system, then the transfer function is equal to c of s divided by r of s, which is equal to, you can write Laplace transform of output divided by Laplace transform of input. Okay, so this is the transfer function of the system when I can say here when initial conditions are 0. So under 0 initial conditions we can say. Okay, so this is the transfer function of the control systems. Okay, right, let us see. Okay, now we will see transfer function of open loop control system. Of open loop control system. Okay, so this is only forward path. We have only system, that is G of S, and this one is output C of S, and this one is R of S. Okay, so this is a controlled output, this is a reference input. Okay, this is, you can call it only forward path. Okay, so this is basic open loop control systems. Okay, therefore how can we mention this one? So Laplace transform output by input is equal to the function. Okay, or I can write this one, C of S is equal to product of R of S and G of S, right? So G of S into R of S, right? So this is the transfer function of open loop control system. Okay, right. Next is we'll see transfer function of closed loop control system. Transfer function of closed loop control system. Okay, right. Okay, so let us see closed loop control system transfer function. So here is the block diagram. This is forward path G of S consisting of output C of S, and this is summing point. Okay, and this will be the input R of S. Okay, now we have a feedback element here, that is we'll write as a H of S. Okay, so negative feedback here, right? So right, so this is our forward path, and this will be the feedback path. Okay, so this is a controlled output and reference input. Okay, see here, output of the summing point will be error signal. Okay, so this will be represented as a E of t, error signal, right? So here the error signal must be 0 so that we can get the controlled output. Okay, so here if error signal E of t is equal to 0, then the output is controlled. Okay, which means what? Whatever the input, there is no error between input and output, then automatically our output is controlled one or desired one, right? If we can say same, if error signal E of t is not equal to 0, then the output is not controlled. Then the output is not controlled. Okay, so let us see figure again. This is G of S, okay, output C of S, and summing point, okay, this is R of S, right? H of S, and this will be the feedback. So negative feedback I am giving here. So this is E of S, the error signal, right? So see here, from here it is a feedback path, okay? So I will write here, this is forward path, as we know this is a feedback path, okay, right? So output of this one I am naming it as Y of S, okay? So output here, what is the output here? Here it is C of S into H of S, right? Now this is Y of S feedback. Right. See here, for a positive feedback, error signal is equal to R of t plus Y of t, okay? For a negative feedback, error signal, that is E of t actually, okay? So E of t, error signal E of t is equal to R of t minus Y of t, okay? Let us see the transfer function of the closed loop system, okay? So let us draw the closed loop again, closed loop system. This is G of S, and this is C of S, the output, and here is the summing point, okay, and this is input R of S, okay. Now this is feedback path H of S, okay, negative feedback I considered here, okay. So this one will be the Y of S, okay. Now what is the output here? Here C of S into H of S, right? This output coming feedback, right? Now this is the E of S, error signal, okay. So let us consider first of all from the figure, from the diagram, okay. So E of S is, see here, the output error signal is the difference between the R of S and Y of S, okay. So R of S minus Y of S, okay. So consider this as a equation 1, okay, right? Now we'll see the only forward path. Now we'll see only forward path, that is G of S, this is C of S, and what is the input only forward path we have? E of S, this term, okay. So now find out the transfer function here, this individual one. So G of S is equal to C of S divided by E of S, right? So this can be written as, or I can write this one, C of s is equal to G of s into P of s, or sorry, or E of s is equal to C of s divided by G of s. Okay, so consider this is equation 2. Okay, now we'll see gain of the forward path, sorry, feedback path. Gain of the feedback path is given by okay. So see here, feedback path is h of s, consists of, see here, okay, see here, see this one. For feedback path, okay, we have input cs, c of s, okay, output is a y of s, okay, so that we need to consider here. Right, okay. Now, so the transfer function h of s is equal to y of s is the output and c of s is the input, or I can write this one as y of s is equal to c of s into h of s. Okay, so consider this as a equation 3, right? Now let us see. Now let us see, substitute equation 2 and equation 3 in equation 1. Okay, so what is the equation 1 we have? Therefore, okay, therefore E of s is equal to, what is that one? The difference r of s minus y of s. This is the equation 1. Okay. Now E of s is what? E of s we have C of s divided by G of s, right? Is equal to r of s minus, what is the y of s? See here, y of s is equal to C of s into h of s. So minimize this one. C of s is equal to cross multiplication r of, okay, we'll go back this one. Okay, C of s is equal to r of s into g of s minus C of s into h of s into g of s. Okay, something. Okay, right. So minimize this one. So C of s plus this term I'm taking this side, okay, right hand side. So C of s plus, sorry, h of s into g of s is equal to r of s into g of s. Okay, now minimize this one. C of s 1 plus h of s into g of s. Take common C of s here, right? So this is r of s, g of s. Okay, continue this one. So therefore C of s is equal to r of s into g of s divided by 1 plus g of s into h of s. Okay, now or this one, so take g of s right hand side, c of s divided by r of s is equal to g of s divided by 1 plus g of s into h of s. Okay, so this is the our closed loop transfer function, okay, of a negative feedback, right? What's my point? So this is the overall transfer function of the closed loop control system with a negative feedback. Right, okay. Now we'll see for negative or positive feedback, right? For positive feedback, so for positive feedback, if I consider unity and non-unity, unity means what? Unity feedback means what? H of s is equal to 1, right? So I can mention here unity feedback and non-unity feedback. Okay, so what is the value of h of s is equal to 1 for unity feedback? Unity means 1, right? So here h of s is not equal to 1, right? Same as, so therefore the transfer functions here, so the transfer function g of s is equal to g of s, I can say this one, okay, we can okay, I rewrite here better. Transfer function c of s by r of s is equal to g of s divided by, for a positive feedback, 1 minus g of s into h of s, right? For for this one, for non-unity feedback, same thing. In this case, h of s is equal to 1. Okay, so I can rewrite this one, g of s divided by 1 minus g of s for a unity feedback, right? For a non-unity feedback, c of s divided by r of s, that transfer function, overall transfer function, g of s divided by 1 minus g of s into h of s. Okay, right. It's responding very slowly, no problem, right? Okay, now for negative feedback, okay, so same, for negative feedback we have unity feedback, okay, and non-unity feedback. Okay, so the feedback h of s is equal to 1 for unity feedback, for non-unity is not equal to 1. Okay, so we'll see the transfer functions very simply here. So for negative we'll get c of s by r of s is equal to g of s divided by 1 plus g of s. Okay, so for negative feedback we'll get the plus here, right? So in this case, for non-negative feedbacks, the transfer function t is equal to g of s divided by 1 plus g of s into h of s in this case. Okay, so this is the overall transfer function of the closed loop control systems. Okay, and in the next class we will move to the order of the systems. Okay, how to calculate the order of the system and type of the system. Then we will move to the block diagram reduction technique. Okay, so minimizing the block as a blocks of all components and finding the transfer function of the given system. Okay, thank you.